So now we are on to 10.2, number 24. This is another great question. I like this one. Let's see if I can make that a little bit more in focus for you guys. That kind of helped. You can read the question on your screen. At a gas station, 84% of customers buy gasoline. Only 5% of customers buy gasoline and a beverage. What is the probability that a customer who buys gasoline also buys a beverage? So, something important here, something of note, right? Probability that a customer who for sure buys gasoline, that's a condition imposed, also buys a beverage. Because there's that condition imposed, right off the bat, I know we're talking about dependent probabilities, right? So I need to know this formula. I saw that Q, it cues me into probability of A and B is going to be equal to the probability of A multiplied by the probability of B, the second event, given that A has occurred. Okay? So in this case, in this problem, the probability that a customer who buys gasoline, that's our event A. That's the one that for sure has happened. But then if they also buy a beverage, well, that's the probability that they bought a beverage given that they bought gasoline. So we need to know those. We need to have this equation on the low ready. All right, so it's there ready for us to go. It says now we just have to match. We have to pull out these values, right? The equivalent ones. It says 84% of customers buy gasoline. So that's going to be our event A, right? So I'm going to call that probability of buying gasoline. I'm just going to call it probability of gas is 0.84. Okay. 5% of customers buy gasoline and a beverage. So that's going to be gas and bev. They buy both, right? And that was just 5%. 0.05. Okay. What is the probability that a customer who buys gasoline also buys a beverage? They for sure bought gasoline, so what they're asking about is the probability that you'll buy a beverage given that you bought gasoline. And that's the one we don't know, right? So hopefully you can see. Here we've got a probability of two events. There's the and, right? Probability of a single event. And then the probability, a conditional probability, right? Hopefully we can see that each one of these sort of has a place up here, right? There's kind of a match. Probability of A in this case, well, that looks like probability of gasoline. Probability of A and B, that looks a lot like probability of buying gasoline in a beverage. And then this one, probability of B given A, well, that looks a lot like the probability of buying a beverage given that you bought gas. With that in mind, we can just sort of substitute these values into this equation and get a result. So let's do it. Probability of A and B, that was probability of buying gas and a beverage. That was just 0.05. And then that'll be equal to probability of A. Well, the probability of A in this case is just the probability of buying gas, which was 0.84. Multiplied by the probability of B given A, which is the probability of buying a beverage given that you bought gas. And that's what we're curious about, right? That's what we want to know. We don't know this value yet. But now we have an equation that only has one unknown. And if we only have one unknown, we can just use algebra to solve for it. So I'm going to divide both sides by 0.084. This cancels out. And here's my value for the probability of buying a beverage given that you bought gasoline, which is also worded as the probability that a customer who buys gasoline also buys a beverage.